Hi there. Welcome to the channel Data Science Demonstrated, where you can instantly see the value of AI and data science. Generative AI is fast changing everything, including on how we do machine learning. So in this video, I'm going to compare the traditional machine learning techniques with generative AI. This will give you an insights into the future direction of AI and also prepare for that. So let's get started, but please do subscribe to the channel, comment and like on the video. Let us take the machine learning problem of sentiment analysis. I will take data related to movie reviews, which are coming from the Rotten Tomato dataset, which is a very popular movie review dataset. The data has got the movie review and the sentiment, and our task is to develop a machine learning model which can predict the sentiment based on the review. Let us first look at the traditional machine learning approach to solve the sentiment analysis problem. This approach involves taking the data, doing the feature engineering, model training, and then the prediction. For feature engineering, we can apply techniques such as the TF-IDF or the term frequency or inverse document frequency, which will convert the review text into numerical columns. The number of columns correspond to the number of words in all the reviews, and the value in each column is the TF-IDF score. And higher the score, more important is the word to the review text. For model training, we can apply algorithms such as random forest, decision tree, or XGBoost, and many others. We can then use the model to predict the sentiment and also compare it with the actual to see its accuracy. Now here is the confusion matrix, and we obtain an accuracy of 86%. Now let us see on how we can solve this problem using generative AI. I'll go through three generative AI approaches: the zero shot prompting, embedding, and the large language model or LLM fine-tuning. Let us look at the first technique of the zero shot prompting. Now in this method, we will take the review, we will construct a prompt which has got two parts: the system part, which will say that you are an assistant which classifies the movie reviews as positive or negative sentiment. Then we have the user part, which will have the review. And then we can pass this prompt to the popular large language models. And here I'm using OpenAI GPT, which will return me the sentiment of the reviews. I've compared the actual review with the predicted review, and I get an accuracy close to 92%. Now, this is very awesome. We do not have to use any sophisticated algorithms such as random forest and XGBoost or any other. So does this mean that all the classical machine learning techniques are dead? It looks like, but let me show some love to these classical techniques and show you a second approach where we will combine generative AI and the classical machine learning techniques. In this approach for feature engineering, we will use embeddings, which are basically the numerical representation of text, which are given by the OpenAI GPT large language model. And then based on these embeddings, we can use the classical machine learning algorithms such as XGBoost for model training. And then we can use this model to give the prediction of the text. I've compared the actual review with the predicted review, and I get an accuracy close to 94%, which is very impressive. Now, even though we are getting great results, why does the generative AI approach does not give 100% accuracy? Now, here are some movie reviews where it could not correctly predict the sentiment. A brutally and a funny work is actually a positive sentiment review, but it predicted negative, perhaps due to the word brutal. Let us look at another example. The most compelling performance of the year adds substantial depth to this shocking testament to anti-Semitism and neo-fascism. The actual sentiment is positive, as the person who gave the review liked the movie due to the compelling performances in a very heavy and a complex story. However, the LLM predicted negative, perhaps due to the words such as shocking and anti-Semitism and neo-fascism. So if we have to improve the accuracy, we need to fine-tune the large language model specifically to the movie reviews, which can contain words such as brutal, shocking, but they are describing the movie story and do not reflect the sentiment of the user about the movie. So let us see this next approach, which is of LLM fine tuning. The fine tuning process takes the pre-trained large language models such as GPT-4 and then customizes it to a specific data set. And in our case, the model will be fine tuned to predict the movie reviews. Now, in this approach, we can take the data, we can do the prompt engineering based on the training data set, and this prompt will also have the sentiment of the review as contained in the training data set. We can then send this training data set to the popular large language models such as GPT-4, fine tune it, which will then give a fine tuned model. And then we can use this fine tuned model to predict the sentiment of any new reviews. I've compared the actual review with the predicted review and I get an accuracy close to 98%, which is pretty impressive. So here is the conclusion I can derive. The classical machine learning techniques may be soon replaced by the generative AI and large language model techniques specifically for the text data. Domain-specific fine-tuning will become important for accurate results. However, the large language model approach is CPU and GPU intensive and is more costly compared to the traditional machine learning techniques. So my friends, hopefully you enjoyed this video. If you want to try out a demo on sentiment analysis using the zero-shot prompting approach, you can do so using my website experiencedatascience.com. You do not require any coding skills and it will be exciting. So my friends, see you soon in another exciting demo video.